Today we are going to learn about exponential and radical form and transferring between the two forms. The formula for exponential form is an a under the radical to the m power with an n inside of the root, which means it's to the nth root, which could be any number. This is the equivalent of a to the m over n power. So we'll use this formula throughout our examples. The first example asks you to take this radical form x to the fifth, and it's the fourth root of that, and rewrite that in exponential form, so only with an exponent and no radical. Anything underneath the radical you rewrite, and then you take the 5, that's your m, so it goes on top of the fraction, and your 4, that's your n, so it goes on the bottom. And this would be your answer. We're going to practice a variety of these to make sure we really understand. Next, we have the cube root of 6x to the fourth power. So whatever's underneath the radical is going to be your base. So we're going to rewrite our base, and we're going to take our inside number, inside the root, to be our denominator, and our outside number, and even if that's slightly underneath the root, it's still an outsider. That can go on the top of our fraction. And that one would be done. So essentially with our formula, we could have the radical with the m on the outside, and this is also equal to that top formula. If you have a problem that does not have a number in the root, and it asks you to rewrite it into radical form, or into exponential form, we can do this by copying the same base, keeping our m on the top, and instead of writing an invisible 1, you actually write an invisible 2 in the bottom, because when there's no root listed, the root is always 2. Let's try one more. So if we had the problem with a 3 on the inside, a 2k, and no number out here for m, you could put an invisible 1 right there. So if it's an outsider, it's a 1. If there's no number listed. And if it's an insider and there's no number listed, that's where it would be a 2. Since we have a 3 listed here, our 3 will go on the bottom, and a 1 listed on the outside, our 1 will go on the top. The same formula can be used if you have an expression that is already in exponential form, so it only has an exponent and no radical. And some people will actually label the original problem. So this is a, this is m, this is n. And then when they go to write the equivalent, they write their radical. The a is the base. So you copy everything that's the a underneath the radical. The denominator is your root, because that's your n. And your numerator is your new power, because that's your m. So you're still following the same template, but you are simply rewriting and switching the positions. Let's go ahead and try a different one. We can label this up, so this is a, this is m, and this is n. So when we're doing our radical, we copy our a underneath the radical. We take our n and we put it in the root. And we take our m and we put it on the outside. Now technically, this expression has this 1 on the outside. That 1 is not necessary. You can actually leave your expression like this. Let's do another problem. Two v is the base, and our formula tells us that the denominator is now our root and the numerator is our outsider. You can use the formula for this, or if it's more helpful to just remember the denominator is the root because it makes something smaller, and the numerator is the power because numerators would make something bigger, that would also work. Our last problem is 7n to the 1/2, where we rewrite our base of 7n underneath the radical, our power of 1, and our root of 2. Now this 2, we said last time, is implied whenever there is no number listed in the radical, so it's not necessary to write the 2 in your final answer. We also spoke about this 1 being implied, so it's not necessary for you to write the 1 in your final answer. Once again, if you're like me and you'd rather be safe than sorry, you can go ahead and keep your answer as so, or you can just keep it as square root of 7n. This is how you would go ahead and rewrite expressions from exponential to radical form and vice versa.